Why is hydrogen actually so difficult? How do you build a hydrogen plant and how do you make the perfect start? What do the business models look like? That's what I want to talk about today. Joining me again is Philipp Glaser from Siemens, and also with us is Stefan Kneipp from Siemens Advanta. And today, I want to talk about the business models.
Get ready for hydrogen. A Siemens podcast with Michael Pretorius and Philipp Glaser.
First of all, a warm hello to you, Stefan. The question, why is it so difficult? I think that's the perfect opening question for you.
Yes, that's a good question, absolutely. And it's really important to answer it, to find the answer to the challenges, because green hydrogen is going to be very important. Without it, we won't achieve deep decarbonization. We simply won't manage it to make certain things green in any other way. We won't be able to produce green molecules. We won't address hard-to-decarbonize industries. So all of this is very, very important. And that's why, yes. But why is it so difficult? That's a good question. There are so many factors involved. Of course, it's something that's really being tried for the first time now. It's not like I can just easily copy this from somewhere. Plants are being built for the first time. There's no copy-paste, no blueprint you can simply follow. There's also, and in general, since all of this is based on renewable energy, there aren't those reliable power flows that deliver the same amount of electricity at all times of day and night. There's simply the added volatility of wind and solar. That's something you naturally have to take care of. And it also turns out, as is often the case with many new things, that while everyone might want it, you can't really do it alone. So this partner ecosystem is important. It's crucial to bring together complementary elements. So yes, it's challenging, but I'm already giving a little hint that there are answers to it.
Now you're with Siemens Advanta. It should be mentioned that this is the internal management consultancy. That means you have very deep knowledge of the software, the hardware, and the tools that Siemens provides. You've already had very deep insights into the first hydrogen projects. And as a management consultancy, you can always share those kinds of insights where you say things like the typical phrases, like the pioneers take the arrows, the settlers get the gold, or the first mover advantage. So where do we stand right now? Why is now the right time to enter the hydrogen business world? Or would it be better to wait?
Well, I think now is definitely a good time. If we take a closer look, maybe even 2 years ago, we had reached an even higher point on the hype curve. Things have now settled down a bit, and we've also reached a more realistic level. But we're also seeing that initial projects have already been implemented on a smaller scale, and larger projects are now steadily moving closer to that crucial investment decision, and some have even gone beyond it. That means quite a bit of momentum has already built up. You can also see that the technologies are scaling more and more and becoming increasingly mature. So, of course, there's still a whole lot of new technology involved, and everything is becoming increasingly robust and resilient. But what's also very important is that things are starting to happen on the demand side as well in a variety of different ways. In various areas. In that sense, and this is of course the key demand is always crucial, I think we're now really entering a much more interesting time frame.
Philipp, in the last few episodes, you kept telling me how important it is to think digitally right from the start. You illustrated this digital twin concept so clearly to me, almost drilled it into me. How crucial it is to work with a digital twin from the very beginning, meaning the hydrogen plant not just to have it in front of you, but to carry out the entire planning digitally, and to implement the operation of the plant digitally as well. Maybe you can give us a preview for Stefan and explain why this digital twin pays off so in the business model.
Yes, absolutely. Stefan put it nicely. Every beginning is hard, and we're starting with something new where there's no long-standing experience yet. The crucial thing is, if I know when I start things and I begin with my first plant and I reach the investment decision with that first plant, then it's important to do things right, because we rarely talk about just one plant being built. We're really talking about how this first one is usually the most difficult. The first one is difficult to fund, to find the right business model and to build it as well it's crucial to get it right to scale up later. That I can then, you're familiar with the topic, we've already discussed it, use templates, blueprints, and scaling of the digital twin to replicate the plant afterward, to make it bigger, to scale it up. Those are the important things. That's the area where it starts to pay off.
Now I'm thinking, with these blueprints, with these templates, looking at it from the economic side, Stefan, you just mentioned it, this planning phase. I mean, we heard it last time in the episode with Mariana, how important it is where the plant is located, what environmental factors are present. Is there wind? Is there sun? Can I get funding there? Can I get regulatory approval? Can I get a permit? Stefan, maybe you can delve into this from a business model perspective. What actually needs to be calculated at the beginning? How does one start?
Yes, well, I think the location is, of course, very important. Mariana already discussed that with you. And it has a significant impact. A good combination of wind and sun, for example, is always a key to success. Or let's say you also look at how many hours per year, for instance, the wind blows and so on in particular. So those are the things you've already discussed. What's also important and what always improves the business case is if you can generally reduce both the investment costs and the operational costs. That's what makes it exciting. For example, when you take a very digital first approach, you simply take advantage of the opportunity that something is being built from scratch on a greenfield site, and you're not necessarily tied to old habits or traditional ways of doing things. So if you can start thinking in a very digital way right from day one, we find that this can lead to up to 10% optimization in CapEx or OpEx, which of course is directly reflected in that famous figure, the levelized cost of X, for example, of hydrogen. That's also a very, very worthwhile step.
Let's make a checklist, a to-do list that you're going to write down for me in my notebook, Stefan. So we're starting from scratch, a completely new project, and we're planning a hydrogen plant. What are the most important and truly crucial first points I need to essentially write in my requirement specification when I begin the planning?
Absolutely. So I think a lot of it will be quite obvious. You're building on renewables. Choosing the location smartly in terms of renewables is key, and also trying to plan the capacity early on. That naturally depends on the size of the plant and the amount you want to produce. Then you also need to consider how it will be financed. So what are the options? That definitely needs to be factored into your considerations very early on. What's really important is the overall sizing. Everything needs to be coordinated with each other to some extent from the beginning. For example, it's also useful to include batteries in the setup to balance out day-night effects or other fluctuations in the power supply. Or does it make sense to install one stack or two stacks side by side, or perhaps a mix of alkaline and PEM electrolyzer? These are some of the aspects that can be optimized during the sizing process. By the way, these are also things that you can't easily calculate or deduce using a simple Excel sheet. That's where important tools come in, like the ones our colleagues and Philipp's team use, which allow for precise and thorough calculations. And that's how you ultimately arrive at the business model. With all the input parameters that have been calculated, it then becomes possible to conduct a proper CapEx and OpEx analysis. This in turn provides much better and more advanced feedback for financing and so on, and for the investors, and then you continue step by step refining the technical design and using the appropriate digital toolchain for that. And yes, hopefully with that and with the right partners you choose, you can then proceed quickly and directly toward the FID. And the critical point there is the offtake. That's something that really needs to be considered right from the very beginning. In which sector, in which industry, or perhaps even into which refined product beyond hydrogen, whether that's a fertilizer or green steel. So in which direction do I want to organize my offtake commitment?
I'm looking at it once again, carefully in these blueprints we've been talking about all along. Philipp, at everything you've prepared, we've talked about renewable energy. Is there enough wind power? Is there enough solar energy? Do I have a constant power supply, or will I have to buy electricity elsewhere at high prices during low production periods? Do I need to be careful with certificates to ensure that the electricity I purchase is truly green if I don't have renewable energy sources on site? These are things you can already calculate in your simulations. Do you already have blueprints for that, Philipp? Or is that something you have to magically pull in from somewhere else?
That's a very important part of the hydrogen performance suite, where we are precisely able to bring together the plant data, the simulation data from the plant, the digital twin of the plant, plus external data. External data could be, for example, the weather forecast or the projected grid tariffs we expect, so that you can make the optimal decision. But it's also the case that in addition to these factors, we can also incorporate overall knowledge about process engineering aspects. Let me give you an example. We recently spoke with a customer based in Southern Europe, and the initial assumption was, well, we can assume that every day around noon we'll have access to free green electricity, and we can run the plant at 100% capacity for 2 or 3 hours each day. But when you look at the full picture, you realize that it just doesn't work that way. Why? Because you can see that the degradation of the electrolyzers increases significantly when operating above 80% or below 40% capacity. And then you can look into it, you can prove that, well, it's not that simple. Because the additional hydrogen you generate contributes considerably less to your business success than the significant degradation you're incurring every day. And that's exactly the point. You need to find partners. Stefan already mentioned it earlier. You need interdisciplinary partners who share this passion, as you put it so well, to bring together this alliance of the willing. People who are passionate about this, who can bring together the experts and who can now guide you through these concepts so that you arrive at a meaningful business model and a viable hydrogen plant.
Let me jump in there, because you mentioned the degradation of the hydrogen plant. In other words, the efficiency of electrolyzers decreases over time as the materials in the cells wear out or corrode. We might have other components that require high maintenance. That means if I run my plant at full capacity to get the maximum output, I might incur costs elsewhere. You can simulate these aspects as well. Philipp, did I understand that correctly?
Yes, absolutely. That's a very crucial aspect. This is where the strength that we at Siemens can bring in comes into play, because we can integrate these different components, including things you can't even measure like degradation. You can't just measure degradation directly. Instead, you have to work with a simulation model on one side and actual data on the other, and then you can capture it. So you really need the systems for that, but also the know-how, and you need data. And that's exactly where we say this is what we can offer. And I believe it's quite unique.
What I'm hearing, Stefan, is that you can work with this data from the very beginning to design a digital hydrogen plant on the drawing board. That also means you can take this simulation data from hour zero and say, not a good idea, or yes, very good idea. Please continue like this, or please consider different financing here, or please choose a different location here.
Exactly. So the simple answer to that is yes. Of course, the devil is a bit in the details, but that's exactly why it's good to work together with the teams on our side and with our partners.
Now I have to ask the question a bit differently, because you both work in very similar firms. Siemens Advanta is an in-house consulting firm, and Philipp is directly involved with hydrogen technology at Siemens, with the hardware, the software, and the tools behind it. So ultimately, with you, I get everything from a single source. And now I'm honestly really very concerned that I might actually become dependent. Or does the significant speed advantage truly outweigh that?
The most important thing is everything is a fully open ecosystem we engage with. We give impulses in different fields to lead and accelerate the hydrogen industry. We want to use our knowledge and technologies to help the hydrogen industry grow faster, get its first plants up and running more quickly, and then scale up more rapidly. What we have in mind is to establish a starting point for an ecosystem. That means we're putting in the first components. Everything we do this is very important, is open. Siemens is known for collaborating with partners at every level. We're doing the same here. That includes partners with whom we conduct simulations together. It includes partners building plants and implementing control systems. It's about an open partner ecosystem in which we now specifically see a hydrogen industry emerging. It needs a bit of a pioneer, someone who takes the lead, who acts as an icebreaker in certain areas, and who can perhaps also help accelerate things here and there. Because the fact is, if I'm a startup now, and if I've actually managed to definitely secure this investment, I have my financing, then of course I need to move forward quickly, because then it's obviously a case of time is money. But we also see it in large companies that then decide, okay, I'm going to free up a budget now and give a department the authority to go ahead and do something too. It's the same. There's an expectation for speed, and that's where we can support together with our partners.
Stefan, you know these partners and ecosystems very well too. Where do you see advantages in speed, or which partners are crucial if I want to launch my plant within a relevant time frame?
Across the entire value chain, there are various partners you need, and that's where our partner ecosystem and our accelerator at Siemens naturally come into play. And I think what is certainly important at the beginning is that you, I would say, increase the chances of success in these kinds of things that, as I mentioned, haven't been done before, and that you maybe also reduce the risk a bit. And that's why you really have an advantage if you can access such a partner ecosystem and the various capabilities we bring together here.
This partner ecosystem is a network. Who do I need? There are regulatory aspects, and politics matters. We have energy providers who play a role, who regulate how much electricity I'm allowed to feed back into the grid. We also possibly have this interaction between, like we discussed last time. Philipp, running a plant means business models vary based on what I want to do with it. Philipp, maybe you can elaborate a bit more on these partnerships or give more detail.
Well, that spans across all areas, whether it's about the manufacturers of electrolyzers, whether it's about facilities, but also operators of facilities. We've already published quite a bit on that, where we've fully equipped entire plants. You can also find some of that on various platforms where you can take a look at it. I think it's a very crucial point, if I may try to briefly summarize it again. We can see that the hydrogen market is currently facing challenges in this regard. Namely, if I produce hydrogen in one location, how does it get to the place where the actual off-taker is? Who will use it, at what price, and over what time frame? And what is he using it for, in what quantities, and what does his demand look like? This kind of midstream, as it's sometimes called, meaning how it gets from the producer to the consumer, what happens there in terms of both logistics and the market? There's still a lot of uncertainty in the market, and many things are unclear. For example, we have customers who have solved this by converting the hydrogen into methane because they use CO2 from a biogas plant, feed it into a natural gas network, transport it elsewhere via the gas grid, and then the off-taker contractually takes it over at that location on a balance sheet basis. These are examples that show what needs to be done and where, on this topic, we can provide targeted support for business models using a management consulting approach, and in doing so, address key weaknesses and obstacles that still exist in this market so that our customers can check them off for themselves.
So what I'm hearing is that we start right at the very beginning. With the simulation data, where do I build the plant? Where do I get the green electricity from? Which factors determine the efficiency of the plant? Do we already have a lot of data available in the early planning stages? Philipp, that can come from your tools? You mentioned the Hydrogen Performance Suite. Stefan, I'm picking up that these are also the crucial data points you need in order to ultimately determine whether financing a plant is viable, whether it can actually be realized. And now we're actually at the end of the process. Namely, who do I actually sell this hydrogen to? What do I do with it in terms of the off-takers? Maybe, Stefan, you can give me a bit of perspective. You just mentioned a model, Philipp, with the methane, feeding it into the natural gas network. Maybe, Stefan, do you have 2 or 3 other examples of business models that might catch the attention of startups looking to enter the hydrogen sector?
Well, there are various applications where hydrogen is preferably used. That's not necessarily the application where hydrogen is reconverted into electricity, because the loss involved, we're talking about what's called round-trip efficiency, is quite high, and it really only makes sense if you have an excess of electricity, perhaps even free electricity in certain places, or electricity for which you are actually paid to take it. So that is, I would say, at the other end of the scales. And then there are areas where it's almost impossible to decarbonize without green hydrogen. Those are the interesting cases. That's where hydrogen is used most effectively, whether it's in or with green molecules that simply can't be produced in any other way, or whether it's the important, increasingly frequently mentioned example of green steel. So these are the areas where it makes much more economic sense, and increasingly more in these cases. Again, that's assuming one continues to pursue this goal. And I hope we do that. We as a society push forward with decarbonization all the way to net zero, then that's the area we should be focusing on.
Correct me if I'm wrong. So when we talk about decarbonizing entire industries, you just mentioned steel with its need for green molecules. We're also talking about the cement industry. We're probably also talking about refineries. Are we also talking about transport? So am I on the right track or am I wrong?
Yes, transport is actually a very good example. The question always comes up, isn't it better to use batteries and electrify directly? It really depends a lot on the distances involved and, let's say, the weight, sizes and volumes you want to move. So I would say perhaps, for example, on container ships and also over long distances, the possibility of electrifying with batteries is of course very, very limited. And that's where hydrogen or its derivative matters, whether that's methane, methanol, or even ammonia is another question entirely. But that is where hydrogen truly demonstrates its strengths in a remarkable way.
So I can already tell, Philipp, you still have a lot of blueprints to develop, because there are so many industries, whether we're talking about steel, chemicals, cement, the transport sector, or that recent example where we have an offshore facility with a few wind turbines and again, an electrolyzer. There are so many different business models. Philipp, Stefan, thank you both very much. I've gained yet another insight, and I'm looking forward to our next conversations.
This podcast was done by humans but localized with the help of AI. Thanks for listening.